So good morning, everyone. My name is Abhilash. So my topic title is range analysis for objective detection algorithms for camera in autonomous vehicle. So everyone is familiar with autonomous vehicle, right? So autonomous vehicles are intelligent machines that will navigate from one point to another point without any human intervention. Okay, so during the navigation, they will observe the environment and make their decision and execute action to do a specific transportation goal. Okay, so these autonomous vehicles are operating in a dynamic environment where they must quickly respond to different obstacles. Like suppose there is an obstacle in front of the autonomous vehicle, we need to suddenly stop or slowing down. This kind of action we need to do. So for identifying the obstacles and for determining how far these obstacles are, we need obstacle detection and distance estimation modules. So this obstacle detection, we can do in different sensors like camera, radar, LiDAR. So in this work, I am using camera for detecting the obstacles and determining how far they are. So object detection. So object detection consists of two components. One is classification and another one is localization. Classification tells you about what the object is, and the detection localization tells you about where the object is in the frame. So the usually in classification and in so there is like alignment issues there. So in classification and in localization, there will be one object in the image. In the detection, there will be multiple objects present in the image. So you will classify and localize multiple objects at the same time. So this is the roadmap for object detection. So over the last 2 decades, the evolution of object detection can be categorized into 2 distinct periods. One is traditional object detection methods. Another one is deep learning based object detection methods. Traditional object detection methods primarily based on handcrafted features followed by classical machine learning algorithms such as SVA or decision trees or XT boots or something like that. So deep learning based methods like, for example, like around 2012, the deep learning became more popular. So after that, like for example, with the introduction of convolutional neural network for image classification, the deep learning becomes foundations for object detection. So deep learning based object detection can be categorized into two: one stage and two stage object detection. In one stage object detection, there will be one network. You will pass your input image and you will get the class probabilities and corresponding bounding box locations. In two-stage object detection, there will be two networks will be there. In first single network, you will pass your input image and you will get the bounding box candidate bounding box locations. That location you will again pass to a second network. So it will refine the bounding box location as well as it will predict the class probabilities. So the examples for one stage are YOLO, SST. Then two stages are like RCNN and fast RCNN and fast RCNN. So all these object detection modes are publicly available. They are trained on Coco or Pascal Oaks, these open source datasets, and it is publicly available for downloading. So what I have done is I downloaded those pre-trained models and fine-tuned on our dataset. So our dataset is called TIA, which stands for TA, the IEEE Autonomous Navigation Dataset, collected in and around the city of Hyderabad. So we have used like multiple 6 cameras, 5 short-range radar, 1 long-range radar, and LiDAR, GPS, these sets. This is a multimodal dataset for perception. So we have published this dataset in the last year IEEE conference. So it is open source. You can, if you are interested, you can check it out. So this is the class distribution for object classes. So person, car, and motorcycles are the most found objects in Hyderabad city. That's what we found. So this shows 2 random scenes from the Hyderabad city with object detection result. So this is the fine. So I took 7 models and I fine-tuned our data set. These are the MAP accuracy values I got. So all of these 7 models performing better. So my objective is to find out how far we can detect objects using existing object detection algorithms. That's all in real time. So that's what my. So this shows the geometry of image formation. So I am using a pinhole camera model. So with the camera, there are 2 kinds of parameters that are there: intrinsic and extrinsic parameters. So intrinsic will describe about the internal properties of the camera, like focal length, principal point, etc. Extrinsic parameters will describe about the camera position and orientation. So there are 3 coordinate systems are there. One is wire coordinate, camera coordinate, and the image coordinate system. So first we will transform that word coordinate to camera coordinate using the expensive matrix. Then we will project this camera coordinate onto the image plane using the intrinsic matrices. So this is for finding out the distance. So the 3D waypoint we will map to image plane using perspective equation. From the equation 1, we can get the equation 2. While rearranging the equation 2, we will get the equation 3, that is the range. So one is for horizontal direction and another is for vertical direction. We want the maximum distance, so we will take the minimum of that. So my methodology is like, so first I place the pedestrian 100 meters away from the vehicle. Then the pedestrian walks slowly towards the vehicle. So the onboard object detection algorithms continuously detect the object. So that point of location I will note it down using a radar sensor. Then the corresponding the object dimensions I will record, and using the previous equation, that range equation, I will calculate the theoretical distance. So these are the evaluation metrics I have used for finding out the error. So this was the experimental setup. So you can see here is the radar for finding out the ground truth. So here is the camera. So this delta X, delta Y represents the actual dimensions of the object. So this is the test bed. That blue shade represents the experiment that I have done. So this is the, actually I have done this experiment at morning, afternoon and evening sessions, and each experiment is repeated multiple times. So what I have found out is that my fine-tuned model is working better than the pre-trained models. That is the one observation. Also, YOLO V7 is performing better. Also, speed inference time also better for YOLO V7, and SSD is performing worse. So then I have compared our theoretical distance with the ground truth distance. So at morning and afternoon and evening session. So actually, it is our theoretical distance is closely aligned with the ground truth distance. That's what I have found right now. So this is the relation between the object size and distance of the different objects from the camera. So whenever the object is closer to the camera, the object size will be larger. And whenever the object is farther away from the camera, the object size will be less. So one thing we need to keep in mind that whenever we develop an object detection algorithms for a longer distance, we need to develop an object detection algorithm that should be capable of detecting smaller objects. So already existing algorithm, what is the advantage is that we can't detect it. The object is very small. So when we develop object detection algorithm, we should keep in mind that we need to develop a neural network that should be able to detect smaller objects. So I am concluding this one. Means I have tested different object detection algorithms in real time. So YOLO V7 is performing better, and SSDs has weaker performance. Even though the DETR and FRCNs are producing better result, the detection speed, inference speed is low. Also, one of the key observations from this study is that the significant impact of the weather condition. So currently, what I'm trying to do is, like, currently I have tested only with pedestrian. I have to do multiple tasks, and also with the different speed, also we need to test how much fast we can detect the objects. Also evaluate the performance in like different scenarios like cars or roundabout or in rainy situation. Yeah, that's all this. Any questions?